Okay, on this next lesson, we're going to be going over inverse functions. We're going to be finding the inverse of a function algebraically. So the key concepts, it says inverse functions blank each other. They undo each other. An inverse function is an inverse relation that is also a function. So the notation is f, and then it has like a -1 exponent. So that's the notation used to represent the inverse of f. So the inverse of f of x is that notation. So we have f to the -1 of x. So it says you read that as f inverse of x. So the inverse of x. So f inverse of x. All right, so the process that we're going to be doing is we're going to first, if we need to, we're going to rewrite the f of x as y. And then once we've done that, if you remember from the previous lesson, to find the inverse of ordered pairs or table, all you're doing is you're switching your x and y. So that's what we will do next, is switch x and y, and then we'll solve for y, and then we'll rewrite it in function notation if needed. Okay, so this first example, we're going to find the inverse of f of x equals 2/3 x minus 2. We're going to graph the function and its inverse on the same grid. Okay, so we need to find its inverse. So first thing, I'm going to rewrite, tells you step by step, rewrite f of x is the same thing as y. Next, I'm going to switch my x and y. So you're not taking that 2/3 with the x. You're just replacing your y with x and your x with y. That's it. Once we have done that, we're going to solve for y. So we're going to isolate the y term. So the next step would be to add 2. So that would be x plus 2 equals 2/3 y. So all I did there was I added 2 to both sides. I'm trying to get y by itself. This next part you can break it into 2 steps, or you can do it all in 1 step. So I like to do it all in 1 step, and then I'll talk about how you can do it in 2 steps. So I'm going to get rid of that fraction by multiplying by the reciprocal on both sides. So those cancel out. We're left with y. And then I'm going to go ahead and distribute that. That's 3 over 2x. And then when you multiply that, that just gives you a 3. So there's my inverse. And we want to rewrite that in function notation. So I'll have f inverse of x equals 3 over 2x plus 3. So there's our inverse. So we're going to graph both of them. So I'm going to start out with my original function. Notice this is linear, so I'm going to use slope and slope and y-intercept. So if you remember from Algebra 1, you always begin with b. So our b in this case is -2, and our m is 2 over 3. So I'm beginning with b. So it crosses the y-axis at -2. And then this is my slope, which means, remember, slope is rise over run. I'm going to go up to right 3, up to right 3, and then the opposite would be down to left 3. And then it's linear, so make sure you connect your points. So there's my original. I'll just label it as f of x. And then I want to graph my inverse. So notice this one's also linear. So slope is 3 over 2, and our y-intercept's 3. So it's crossing the y at 3. And then my slope is 3 over 2. So I'm going up 3, right 2. And then opposite would be down 3, left 2. I'll label this as f inverse of x, so that way we know the difference between the two. All right, so there is how we find the inverse of an equation or a function starting out. So we're going to switch x and y like we did on the last lesson, and then we'll have to solve for y on our equation. So remember I said I would go back over of how you could do that in 2 steps. You could multiply by 3 on both sides and then divide everything by 2. So it should give you the same answer there. All right, let's take a look at the next example. So we're rewriting our f of x as y. So start that out. We're going to switch our x and y. Remember, don't take anything with it. We're just replacing them. And then we're getting y by itself. So I'm going to subtract 6. So that's x minus 6 equals negative 3y. And then I'll divide everything. Make sure you divide every term by negative 3. And since it's just an x there, I'm going to go ahead and put a 1, so that way I know it's negative 1/3 x. That's going to help me with the slope. And then a negative divided by a negative is a positive. That should be plus 2 there. I'll just put that inverse symbol. And then we're rewriting it in function notation. So we're going to have f inverse of x equals negative 1/3 x plus 2. And then we're going to graph them. So I'm going to start out with my original. It's also linear, so I'm going to use m and b. So m is the slope. In this case, it's negative 3/1. We have to put it in fraction, rise over run. And then the y-intercept, which is your b, is 6. So that's what you begin with. So it crosses the y at 6, at the very top. And then we're having to, since it's negative 3, we're having to go down 3 and then right 1. Down 3, right 1. Continue on until you can't plot anymore. And then you'll draw your straight line. And then graphing our inverse. So the m is negative 1/3, and then your b is 2. So it crosses the y at 2. And it's negative, so I'm going down 1, right 3. Down 1, right 3. And then opposite would be up 1, left 3. And I'll go ahead and label it. It's my inverse and my original function. Okay, so we're finding our inverse function algebraically, and then we're graphing both of them on the same grid. Let's look at the back. So now we're going to be verifying inverses. So it says, you know that the inverse function You know that inverse functions undo each other. Mathematicians apply that knowledge to determine whether or not two functions are inverses of each other by using compositions of functions. So you probably have seen this in Algebra 1. So it says two functions f of x and g of x are inverses if f of g of x equals x and g of f of x equals x. So basically you're taking one function and plugging it into the other in place of your x, and then vice versa. Once you put it together, it should equal x if they're inverses. Okay, so we're going to, example 4, determine if the functions are inverses using composition of functions. So first thing that I notice here is I need to go ahead and distribute this. So if you end up having parentheses starting out, go ahead and distribute. It'll make it easier. Okay, so starting out, I need to do f of g of x. So what I want you to do is I want you to write that down. And then on the inside, on a composition, the inside is always your input. So I'm going to replace my g of x with what it equals. I'm going to use a different color so you can visually see it maybe. Okay, so what I'm going to do here is I'm going to look at my function f, and everywhere I see an x, I'm going to replace it with this input, which is 1/2 x minus 1. So I'm going to have 2 open parentheses, instead of my x, I'm putting 1/2 x minus 1. And then I have the plus 2. So I took this equation, and instead of x, I plugged in the input, which was 1/2 x minus 1. So now I'm going to work it out. So when I distribute, 2 times 1/2 x is just x minus 2, and then the plus 2 that you're bringing down. So notice those cancel, it equals x, which is what we want it to equal. Now we're having to do the opposite of that. Now we're having to take, because if you have to plug in both. So I'm going to have g of f of x again, your inside is your input. So what I want you to do there is I want you to replace your f of x with what f of x equals, which we multiplied it out, 2x plus 2. So now I'm looking at function g. Here's function g. Everywhere I see an x, I'm replacing it with this input. So I'm going to have a 1/2, open parentheses. I'm putting 2x plus 2. And then I need to subtract 1. So I looked at this equation here, and I'm replacing my x with that input. So now I need to distribute. So that's x plus 1, and then minus 1, which those cancel, equals x. So both of them equaled x, which means, yes, these are inverses of each other. So there's your answer. Okay, so it might look confusing at first, but once you get started and you practice it, then you should get better at it. So take one function, plug it in, and replace the x of the other function. Also, here's a process for you if you want to read that. Maybe that will help you. Okay, so let's try another example. All right, so I'm going to take function f, and I'm going to plug in g of x. So again, it's helpful if you actually replace what g of x equals, which is x over 5 minus 4. So I'm going to have f, and then x over 5 minus 4 is my input. So we're looking at function f, which is right here. I have a 5, open parentheses, but instead of x, I'm putting my input, x over 5 minus 4. And then minus 4. So I'll have to distribute. That just gives me an x minus 20 minus 4. That's not going to equal 0 there, so that does not equal x. Now you might want to check your work here. You can even go back through and work it out again. If it doesn't equal x, just make sure that that's true. If it doesn't equal x on that one, we know that this would be not inverses, so we would write no. Okay? All right, so you can pause the video, work on part C by yourself, and then I'm going to go ahead and give you the answer. So go ahead and pause it, work it out, see if you get the same answer as me. They should both equal x, so yes, these would be functions or inverses of each other. All right. The next part, values of inverse functions. If values of a function are provided on a graph or table, values of its inverse can be determined from the graph or table of the original function. So use the graph or table provided to evaluate the function and its inverse at the specific or specified values. Okay, so we're given a graph and it says f of 1. Anytime we have function notation, remember that's usually f of x. So that's telling me x equals 1 here. So I need to go on my graph, find x equals 1, and go down and see what the y value equals. So when x is 1, your y value is -2. Now I'm doing the same thing on the next one. This tells me x equals 0. So I'm going to go to x equals 0. I'm going to go down on my graph, which is right here, x equals 0. Your y would be -3. Now, this is the tricky part. Now, remember we said to find the inverse, all we're doing is switching our x's and y's. So this tells me the inverse of f, or f inverse, which means now I'm looking at the y value of -2 because we would end up switching them. So look at the y value of -2. So here's your y-axis. Go down to -2. It would be this point here, which would be 1 on the x. Same thing here. This means the opposite. So really they're giving you the y value. So go to -4. Go over. And so your x would be -1. So those are a little tricky. So if it says inverse, you're looking at the y value, because remember when you find the inverse, you switch x and y. Okay, so that's from a graph. Now let's look from a table. So f 15, which means x equals 15. So when x is 15, your y is 3. F of 55, when x is 55, your y is 7. F inverse of 3, which means, remember, you switch x and y. So you're looking at the table when your y there is 3, which would really be your inverse x. It would be 15, and then 5 would be 31. Okay, so these are inverses. We're finding the inverse algebraically, and then we also learned how to verify if they were inverses or not. Let me know if you have any questions.